What if we put a cup of coffee at 60 degrees Celsius beside a cup of water with ice at 3 degrees Celsius on a tabletop at 18 degrees Celsius? After a while, the temperature of the cup of water and the surface of the table will increase to an equal temperature with the cup of coffee. This phenomenon occurs naturally in our lives constantly and is a simple explanation of the zeroth law of thermochemistry. Thermochemistry is a crucial area of study that helps understand and predict chemical reactions and physical changes. It uses laws of thermodynamics to transfer and transform energy, making it essential in fields like chemistry and physics. Thermochemical equations help scientists calculate energy and design efficient processes. It also has practical applications in everyday life, such as cooking and heating homes. There are two fundamental principles of thermochemistry are, I, the energy change associated with any process is equal and opposite to the reverse process, due to Laplace, and, 2, the energy change for a series of stepwise processes or reactions is the same as that of the entire process, Hess law. Thermochemistry is a branch of chemistry that deals with the interrelation of heat with chemical reactions or physical change of state. For an endothermic process, where energy is put in, we see this energy included on the reactant side absorb energy. Reactants plus heat equals products. Electrolysis, decomposition, evaporation are considered as endothermic reactions. For an exothermic reaction, which energy is going to be released or produced as relative result of this chemical reaction, we are going to see it on the product side, release energy. Reactants equals products plus heat, combustion, neutralization, and most oxidation reactions are considered as exothermic reactions. Basic concepts in thermochemistry. 1. The nature of energy. The forms of energy include thermal energy, radiant energy, electrical energy, nuclear energy, and chemical energy. 2. The first law of thermodynamics. To study the flow of energy during a chemical reaction, we need to distinguish between a system, the small, well-defined part of the universe in which we are interested, such as a chemical reaction. 3. Hess's law. Hess's law argues that delta H for the net reaction is the sum of the delta H values for the individual reactions. This is nothing more than arguing that delta H is a state function. For enthalpy, heat refers to a process in which a body, the contents of a tea kettle, for example, acquires or loses energy as a direct consequence of its having a different temperature than its surroundings. 5. Calorimetry. There are different types of calorimeters, and they are classified according to the purpose for which they are used, and among the most important types of calorimeters. Bomb calorimeter. Used to measure the heat evolved in a combustion reaction. Coffee cup calorimeter. You keep your hands warm when working or playing outside on a cold day. A common hand warmer generates heat when it is ripped apart, exposing the iron and water inside to the oxygen in the air. The exothermic process is one condensed version of it. And the heat produced by this process is absorbed by your hands as the reaction is catalyzed by the salt in the hand warmer. Heat is produced more quickly. Solar thermal energy power plants. A solar power plant is a facility that converts solar radiation, made up of light, heat, and ultraviolet radiation, into electricity. The most widely used flat plate collectors consist of a blackened metal plate, covered with one or two sheets of glass, that is heated by the sunlight falling on it. This heat is then transferred to air or water, called carrier fluids, that flow past the back of the plate. The heat may be used directly, or it may be transferred to another medium for storage. The thermal energy is used to store the energy as chemical potential. Thermochemistry's vital importance. Thermochemistry plays a vital role in various fields, including industrial processes, environmental science, and the development of new materials and energy sources. Here are some of the key areas where thermochemistry is important. 1. Energy production and storage. Thermochemical data helps researchers understand the energy changes involved in reactions, enabling the design and optimization of efficient energy conversion and storage systems, example, batteries and fuel cells. 2. Environmental science. Thermochemical properties are crucial for modeling atmospheric chemistry and predicting the fate of pollutants in the environment. 3. Industrial processes. Thermochemistry is essential for designing, optimizing, and monitoring industrial processes such as combustion, gasification, and pyrolysis. 4. Material science. Thermochemical data is important for understanding the stability and reactivity of materials, enabling the development of new materials with desirable properties for various applications, such as advanced materials for aerospace and electronics. 5. Biochemistry and life sciences are essential for understanding biological processes and drug design through understanding metabolic pathways, enzyme catalysis, and protein folding. Thank you for joining us on this journey through thermochemistry. We hope you now have a better understanding of the relationship between energy and chemical reactions. Remember, energy is all around us,